Excellent. So we're right to go. All right, we're introducing April Ullery today. We're very lucky to have her along. She's a professor at New Mexico State University, who's a lecturer in soil chemistry, and research and interests are in soil quality, particularly in the environmental sphere. She has strong involvement in past presidents of Soil Science Society of America, and today she'll be introducing us to the Soil Society of America's Glossary of Soil Science Terms. So thank you. Take it away, April.
Thanks, Megan. I appreciate that. And thanks for the invitation to speak. This all kind of started, was it only a year ago when, Kath, you approached me as president of the Soil Science Society about using our glossary. And so that's something that frankly I'd kind of forgotten we even had. So it's been fun to find a new resource or an old resource and remind myself about it. First off, let's see if we can, there we go. I wanted to orient you. Did you see the big map here? So this is just North America. And isn't it a beautiful map? It occurred to me when I was visiting with Megan last evening that, oh, see, now I got to be careful, that you guys may not even know where New Mexico is or New Mexico State University. In North America, New Mexico is on the border of Old Mexico in the Southwest United States. I'm in Las Cruces at New Mexico State University. And you can see there's a lot of mountains, a lot of the Rockies, active tectonic area, and a lot of desert. So one thing I didn't realize is that I wasn't going to just be able to use my arrows. Okay, so for the glossary of soil science terms, here's the website for it. And another interesting feature is that currently this is a free resource, although it turns out that I'm sure the updated one will probably not be free. But this is simply a glossary, an alphabetical listing of soil terms and SI units, conversion factors, measurement terms. In our last 2008 print, I think had about 75 pages. The newest version that I have, and I have a PDF file of it, has 236 pages. So we've expanded quite a bit in the 12 to 14 years since it's been updated. But the Soil Science Society of America has had definitions or glossaries provided for their members since at least 1956. So what is this resource? It's just a glossary, a simple dictionary, not one that has the etymology and all of the interesting history of the words that I find fascinating. But it does have a lot of still obsolete terms in it, which is kind of fun to find. We haven't just thrown out all of the old terms just because they're no longer supported or used in publications. And speaking of publications, that's really the point of this glossary. It was originally published to provide both a foundation for common understanding as well as communications covering soil science. And what that means is publications, trying to get everybody on the same page using the same terminology is, as you all know, very critical. But the other caveat here is that none of the terms that are listed here are considered official. And I don't even know what that means. I don't know what official means. It's not like these are only for the use of the soil science members or anything. So this resource has been created and it's copyrighted, updated, and supported by the Soil Science Society of America. We used to have our own publications in-house. Now we work with John Wiley and Sons as an external publisher. As I mentioned before, the old version from 2008 is free online, but the new version will probably require either membership to get it, or there might be an opportunity to purchase it just singly and then download it as a PDF. So as a PDF format, the only way you could search for terms is to use the Control F for find feature. And the online version will have both search and browse features. So a search box where you can put the word in that you're looking for, a browse feature where you just can go to the letter of the alphabet you're interested in. And then other points like in the appendix where you want to maybe look up conversion factors or other terms. Okay. So while we have a glossary and ours is certainly growing and everything, I also want to point out something that probably all of you have on your bookshelves, and that's at least one of the editions of the Glossary of Geology. Mine was literally from the 70s. Megan and Kath and I were talking about things from the 70s. That's when I first got interested in geology. And I loved that book. And it was a big paperback book at the time, but now it's humongous, over 800 pages with 40,000 entries and a hefty price tag to go along with that. And the point I make here about whether it's a profit maker, that's something our society is always looking for too, is ways to find things that people might want to purchase and make the society some money on the side. Doesn't help the researchers, but okay. Oh, sorry. So here's a screenshot of the current glossary of soil science terms. And a couple of things to note here is that I'm not logged in. So this is open to the public as it currently stands. What else do you notice here, if you can even see anything? There's a lot of terms that relate to the soil taxonomy, like A horizon. There's terms that relate to chemistry, like absorption. There's microbiology indicated here. So what you're seeing is, just as the nature of soil is very interdisciplinary, this glossary is also very broad in range and interdisciplinary too. This isn't set up like a Wikipedia page. It's not something where individuals who have like an editing right can go in and fix things or change things. So if you see a mistake or want to add a word, we have instructions on how to go through the publication's managing editor, and she will help get that added, either in the online version or for the next print version. And I already mentioned that it doesn't include anything, none of these entries, none of these definitions include anything about where the word came from or the historical nature of it. And that's something that I think could be helpful. Geez. Okay, so here's some more just screenshots, or I've pulled out parts of these definitions, and I wanted to share these to kind of point out a few features. For example, up here on the soil classification part, you know, that just tells you that that particular word, which of course I can't see because of this, azonal soils, that's something that's in particular use for soil classification and taxonomy. Although notice that it's not used anymore, it's an obsolete word. And, you know, but we still have the definition for you. Notice also with the red circle, there are references listed throughout the book. And I have so far been unable to find where those references are listed, but I think they're referring back to earlier glossaries or other field guides and methods books that where the word has first been used. And then because we're interested in relationships and communication, I look for words like compare, and those are included to let you know what other words might have something to do with this word. So back barrier beach, maybe that's not the one you found, but if you look at barrier island, that's a similar definition or similar use, and something that could be useful for our purposes. Help. You can't do this and be nervous also. So the glossary as a publication guide is useful because, again, some of these terms are either no longer used in our publications or they're not used in soil taxonomy in the United States. I won't speak for all soil taxonomy, but at least the NRCS, the Natural Resources Conservation Service in the United States, doesn't adhere to some of these old terms. But they're, again, very useful to have those definitions. So while the definitions that we look at mostly are static or based on just the word itself, some of them are based on methodology. And if you look, and if you know anything about soil microbiology and organic chemistry, you realize that the fulvic and humic acids are, at least until relatively recently, defined based on their reactivity in reagents. And it's more of a process definition where we define fulvic acid as something that's still remaining in solution after you've acidified the solution and removed the humic acid. Or in the case of humic acid, it can be extracted from soil using a dilute alkali and other reagents, and then you precipitate it by acidification. So these are interesting because they're methodological based and not, we don't have like a chemical formula for fulvic acid yet. But as I understand it, that's on the horizon, and that's new stuff coming up. And that's also kind of a challenge that glossaries or websites, either one, have, and that's trying to keep current. And especially if you're putting these all in print form. Okay. So something to consider based on the methodology, and if any of you have any suggestions on how I can stop flinching so much, that would be great. The Soil Science Society of America has this phenomenal series of methods of soil analysis books. We call these our brown Bibles, and they're literally compilations of methods from way back in the day, way back in the early 20th century, all the way through current things. What's exciting about these is that they are, I believe, now available to purchase by chapter. In the old days, you would literally get, a 4-inch volume of, say, the soil chemistry methods of soil analysis. Would just be huge and impossible to use as a lab book. But now you can purchase the PDFs of individual chapters or download them. So something I found really fascinating as I was going through both the 2008 glossary and the 2022, the latest version that's getting ready to be printed this year, is that language changes over time. I'm sure that's not a surprise to any of you. But when I say language, I'm talking about specific words that we use to identify things. And the best example here is something like soil quality. Back in the 50s, 60s, and 1970s, we didn't use the term soil quality. The terms that were used back then, I was in graduate school in the 80s. What I heard a lot about was soil physical conditions, or just soil condition. And that's the kind of terminology people thought about or used when they were describing a really good soil, meaning a soil that was a good yield producer. Because again, soil science is largely based out of the agronomic discipline. And we look at healthy or high quality soils or good conditioned soils as something that supports its functions, supports its plant life. But notice that both in the 2008 and then this is the latest version, there's nothing about soil health here. I looked it up, and that's a big term now, or since the early 2000s, and we even have a Soil Health Institute. So there's changing language that isn't always reflected in these definitions. The other thing is I'm also seeing, as I publish papers, I have one coming out in an encyclopedia, a chapter in an encyclopedia of soil science, and they didn't even want to use the word health. What they are insisting on using is soil status. So they're not even giving it any kind of a judgmental call. They're just saying, here's what the measurements are. Okay. Another thing that you can look for is specific terms. And I got these terms from an email that Kathy and I were exchanging last summer when we were trying to figure out if the Soil Science Society glossary was something that could be useful to ESIP. And she gave some examples in there of terms that might be important and overlapping disciplines and that kind of thing. So I thought, well, I'll see what our glossary says about, say, soil organic carbon. Well, I couldn't find it in either the 2008 or the latest version, the unprinted version yet. So I instead looked for just organic carbon, which, using the control find feature, I found 25 definitions of soil suborders and diagnostic horizons use organic carbon in the definition, but the term organic carbon itself was never defined, which sort of seems like, is that a catch-22 or an oxymoron? I don't know, but that seems problematic. The other thing that I did was, so I just browsed through all of the C words, and I looked for carbon, and I found carbon cycle and carbon nitrogen ratio. That was pretty much it. But I found nothing about the forms of soil carbon, including inorganic forms such as caliche or carbonates. Now, I did find caliche, that's a colloquial term because it's only used in certain areas. And, someone from Wisconsin wouldn't even know to look that up. Okay. But new in the latest version is carbon budget. And it's defined as an accounting of inputs and outputs of carbon in the soil and ecosystem. But again, like the soil organic carbon issue, there's no definition of the various forms that carbon might take, either as inputs or outputs. I also browsed the O words, organic, organic soil versus mineral soil, organic soil materials, and then I found soil organic matter, C humus. So again, you kind of have to know what word to look for to get into the right category even. Another word that popped up on my radar was bulk density. And partly because this is a word that is used in a lot of disciplines, and we just kind of wondered, if it's defined differently by other disciplines. Ours is a very simple definition: mass of dry soil per unit of bulk volume, and what the unit is reported as. But no information about how it's measured. You could look in the methods of soil analysis books, and also no connections with other research communities. So that's it for the glossary, and we're already at 5:30, well, at 34 minutes after the hour. So the rest of my slides are really just a discussion of how soils form, if that's of interest or help to you, or we could start our discussion. I'll leave it up to you guys.
So, hello, sorry I was hiding for so long. I was here, but
Yeah.
So I know you said that soil health isn't in the current versions and stuff, but wasn't tilth in the old version?
Oh, okay. I didn't see it, but I do have it popped up if you want me to look. I can look for that. But yeah, and that's a very good point, Tanya, because the NRCS actually has, or it had, a soil tilth lab, and then it became the soil health lab.
Right, because as April knows, I was not originally trained as a soil scientist. I was a geologist. So when I came into soil science, everyone would be like, tilth, and I had no clue what they were talking about. But exactly. I think that was the concept. The other thing is, you made me think of something that I'd never brought up in here, because I do have two, like, I never used the geology glossary, but I used these two. Can you see them? I don't know if this one's showing up very well.
Yes.
Those are, so these are the two Bibles that I combined with the clute and such that April mentioned. Yeah. I mean, I still cite clute almost all the time. I guess I cite Gee and Bowder, for example, all the time.
Yes, exactly. Me too. Got it memorized.
Yeah, kind of.
So as someone with who originally trained as a mathematician, I would be really interested in getting a classic primer on soil science, if you don't mind, April. If
that'd be great.
Don't mind.
So I'll just zoom through these. Some of these slides were actually made by the Soil Science Society of America marketing team. So they're, again, available online and for teachers. And some of you have heard of the classic term chlorupt. My students prefer to remember it as port C. And all these refer to is the 5 factors that control how a soil forms. So we're talking about parent material, organisms, relief or landscape, time, and climate. So the various factors, probably most people would agree the most important soil forming factor is climate, and that essentially is all about weathering, exposure to how much water you have and what temperatures, not only the extreme temperatures, but your fluctuations. You also have parent material, what you start with. Organisms include plants and animals and humans, although some people are now wanting to actually pull humans out into a whole separate distinct category. So maybe there would be 6 factors of formation instead of 5. Relief refers to the topography, slope, or aspect. And this really goes back to weathering, because it's all about how much water can get into the soil. If it all runs off, it doesn't do any good. It doesn't weather anything. However, temperature is also affected by aspect. If you're facing the sun, you get more warmer temperatures and more weathering than, say, on the backside or the dark side of the hill, where you might have more water but not as much heat. And then time is a really, in my opinion, poorly chosen word, since we're talking about words here. And that is, it's really about how long the soil has been exposed to the elements, not so much just a linear time frame or a clock. And here's an example, if you can see it. Here's an example of the effect of rainfall on calcium carbonate, which we call lime or caliche in southwestern soils. And if you look at the development of soil going from a very dry area on the left to a relatively moist climate or area on the right, you see that calcium carbonate, which is a soluble compound, goes deeper into the soil profile, and it might even be exposed at the surface out here in an area like New Mexico, where we only get 10.5 inches or 267 millimeters of precipitation or rainfall a year. So we don't have anything to dissolve it or to, it turns out that calcium carbonate just precipitates right out of solution around the rocks and pedons in the soil. So increasing rain gives you more plants, which makes the soil more acidic, lowers the pH, increases the amount of dissolution that you get and leaching, giving you a deeper soil and a deeper accumulation or depth to the calcium carbonate horizon or yeah, I guess it would be like a calcic horizon. So examples of organisms that, you know, obviously you look at any crop or forest or something like that, and it's easy to see the roots are doing their business by releasing carbon dioxide, forming carbonic acid, and weathering, but, you know, and adding organic matter to the surface. But as Tanya and I know, because our professor was a big one on root weathering, you know, what actually broke apart rocks in the Sierra Nevada, you know, you can just have these roots creating mechanical weathering forces. And of course, organisms can include microbes, burrowing animals, and as I mentioned before, human impact. The impact of topography on water movement and soil development is really logical. If you're flat, you have you know, more chance of water hanging around and infiltrating into the soil. If you're on a slope, where's the water going to go? Down, right? So deeper soils are found in areas either on the residuum, these plateaus, or collected as colluvium and alluvium down in the valleys. And you can see some of the differences that you might find soils that form in a limestone and with a lot of organic matter at the surface. The white stuff is the calcium carbonate. And then soils on the right were formed in a lacustrine, a lake bottom. And these are, you know, one of the inherent qualities that a soil might inherit from its parent material is the texture. And a lacustrine parent material is going to be a lot of clay and very fine textured compared to some other types of parent material. And then time, of course, looks change with time and as do soils. So the older a soil gets, the more different it looks from its parent material. And what I did here was I just showed you, let's imagine a block of uniformly deposited parent material. It could be just a block of that lacustrine parent material there that there's no differentiation. But then as you expose, as you expose the soil to weathering and all of the processes that are going on, then you can add things, you can remove them, you can transform them, you can lose them. And older soils look much different from what they started out as, because of all of these chemical and physical form transformations that are happening in the soil head-on or in the soil environment. So something to consider is that soil actually, a soil profile is like a snapshot in time. And this is the part that a lot of people have a hard time understanding, is that soils are dynamic. They are constantly changing. And just because you went out and collected a bunch of soil samples 50 years ago or 5 years ago doesn't mean that it's going to be the same properties. There's spatial heterogeneity, so it's very unlikely that you're going to go out and collect the sample from the exact same spot you collected the first sample from. But over time, things are changing. Now, we say they're not changing on the order of 50 or 5 years, but things that are like nutrient levels, organic matter levels, things that are so important for agronomists and plant growth, those might be changing at least up in the surface of the soil. But we always caution people, you know, it took this surface, just this surface 1 inch probably took, you know, thousands of years to form. So don't let it blow away all in one dust storm. The other thing about time is that the clock at time equals 0 can actually be restarted multiple times when you have a landslide, you know, and all that colluvium and rock falls down on top of your soil. Now you have a buried soil, and you're starting the clock over at time equals 0 with this new landslide. Or if you have a flood come through, that's essentially starting time at 0. So really your oldest and most well-developed soils are those that have been on flat residuum or, you know, stable landscapes that have the most time to just kind of weather in place. But we can look at time soils like in the Antarctic. Those are centuries old, but they might not be very developed because they've been buried under glaciers and not exposed to any kind of weathering. Then please just stop me when you're ready for me to shut up. But to me, one of the most interesting things about soil and soil formation is the way you get different soils forming in different parts of the landscape. And these block diagrams are incredibly useful for seeing how your, again, your more stable landscape has the more well-developed soil, something that gets renewed or refreshed with every flood. Might be called an entisol for recent, an entisol for recently deposited. And then you have, you know, in between where you've got now stable terraces forming. One other thing I notice is that our previous definition of soil in 15 years ago was just that the layers of generally loose or unconsolidated mineral or organic material, you know, are affected by all of these processes at or near the surface and usually hold liquids, gas, biota, and support plants. Now we've got a much longer, much more comprehensive definition. So my question is, as time goes on, do we just get more verbose? And how much of this is needed, I don't know, but it's just new and different definitions.
So April, before you
Yes.
go much farther, there's like kind of a hot talk or a hot discussion about what soil health really means and if it's a real
Yes.
concept.
Okay. Because I haven't been able to read the chats while I'm presenting.
Right. So
Should
Kara,
we?
are you the one who said something about soil? You were the one talking about ocean health, right? So like, I don't know, April, for me, when I talked with NRCS most recently, the concept of soil health is, you know, whether or not it is a mishmash and they don't even know how to measure it necessarily. There's a whole range of things that go into measuring it, right? There's the microflora, like what enzymes are in there, how well does it transmit water, what's the organic carbon content. I feel like those are the big ones that I hear about. What do you hear about when you hear about soil health definitions?
Well, it's interesting that you say that. And that's why I mentioned that at least for a lot of people, the soil health, it's supposed to be defined based on the ecosystem function. And if that function is to serve as a wastewater treatment pond, then yes, you don't want organic matter. You want dispersion. You want certain things. So it's all about what you say the function is. If the function of that soil or ecosystem is to grow plants, either agronomic or native plants, then that changes what the qualities are that you're looking for. That's the way I understand it. It's been conscripted. It's been grabbed by certain disciplines because they want to use the concept to, in my opinion, to support their functions, their use of the land. And that's fine. And they're always good about going back to that first definition of what's the function. But I try to convince someone that my desert soil is perfectly healthy. It is for what it's functioning as, which is, to serve as a home for the Chihuahuan Desert ecosystem. It's perfectly healthy for that. Then you get this other argument about, and this is why soil quality was dropped. People start looking at the term quality in terms of environmental impacts. Like when we talk about air quality or water quality, we're talking about how contaminated they are. And if we then apply that to soil quality, well, that sounds like we're talking about how clean it is. And that, so again,
and potentially evaluating the cost of people's or the value of people's property, which is seriously dangerous. Yeah.
And land costs could go down, which is a really good point, because we've talked about, how important it is to identify where you're sampling and the location. But I have farmers and, landowners who don't want me to include, their location, because once I've found lead on their land, hey, that's no one else's business, right?
Yeah.
Except the agents that are deal with it.
Yeah, sorry, Kath. I was thinking, should we stop the recording now? I'm just looking at the clock. This is a really interesting chat, but I'm thinking some folks on call might have some questions also about the soil glossary. So did you want to stop the recording?
Thanks. I'm going to stop the recording now. Thank you so much, April.
Yeah. Thank you very much.